Welcome to the Southwest Climate Podcast October version. Mike Crimmins.
Hey, Zach. It's still October, right?
It's almost November, actually. It's the end of October. So, wow.
Yeah, we haven't gotten together in quite a while.
That's right.
It's a busy October. Yeah.
The monsoon was still going officially. In fact, I have to say that this is our second podcast today. So those of you be on the lookout for a separate podcast where we could not let the monsoon die without getting our friend and Phoenix colleague at the National Weather Service to give us his take on the monsoon. So be on the lookout for that. And this particular podcast, Mike, we'll do our normal shtick, which gets people up to date on what's happened recently around the Southwest. We'll dive a little bit into water issues because it's the time of year when all eyes in terms of climate impacts turn to our rivers and the water supply and the snowpacks in the upper basin. And, you know, we've got a full-fledged or close to a full-fledged La Niña in the works. So we'll talk a little bit about that. But other than that, Mike, how do you feel?
I feel good. The weather, it's just the magical weather turn down here in the Southwest. You know how obsessive we talk about dew points kind of early in the monsoon season and like, okay, we're not at 54, 55, or it's got to be a little higher. We can't do that. I was so done with dew points in September. I couldn't wait for it to dry out. And so it's actually finally the dew points are down in the 20s here in Tucson today. And the mosquitoes have actually started to wane. So,
so that's what I was going to ask you, because I'm still being ravaged every time I go on my porch with mosquitoes. So what is it? Is it the temperature? Is it the humidity? Is it when do those things go away?
Southwest entomology podcast right here. So what I heard on the news, and it was an entomologist, it's something to do with like these cycles or broods of mosquitoes. And that if it doesn't rain for like 2 weeks, you get this they start to decline and wane. But I guess if you have standing water or wet soil,
I need to drain my swamp cooler. That's what I decided last weekend. I was like,
do you think they're in there?
I don't know. I mean, it's standing water.
You should take care of that.
I will. What else do we have to talk about? No. Okay. So
I don't even know. That's the end of the Southwest Entomology Podcast.
Maybe let's start, Mike, with a recap of, what we have to start with is to mention the final results of our Southwest monsoon fantasy forecast, which by all accounts, and mine is the most important, is it was a real big success. So I just want to thank everybody for playing. It was a lot of fun, and we had some intrigue at the end. We crowned a winner and a second place, and they got these really cool weather stations. We're going to do it again next year and the years after, so be on the lookout. But the intrigue happened that the entire leaderboard, the top 10 leaderboard, shook up in the last couple days because Albuquerque and El Paso got some rain on the last night, I think. And so the winner, whose handle is Esma Grace, and there was a write-up of her and the second place called Mesquite Nerd in the Arizona Daily Star on October 5th, Esma Grace vaulted to first place, I think from like 8th or 9th, and the second place vaulted, from behind as well. So that was pretty fun that unfolded. And more importantly, they supplanted our own Ben McMahon as winners.
He almost won the inaugural monsoon fantasy. So it almost looked like a super inside job. Right at the end.
And so we're really, really happy about that. Yeah, so the funny thing, I'll just tell this little story, and it's in the Arizona Daily Star, but the winner actually had just recently moved to Tucson from outside of the Southwest and was like, a weather person, but, obviously hadn't experienced the monsoon. So I thought that was really great in part because there is randomness to figuring out the monsoon, and I think we at least have an N of one in our data set of that. So the winner basically knew nothing about the monsoon. And so kudos to her. Mike, you finished a whopping 120th?
I think it was 103. Come on, man.
Sorry about that. I did beat you. I came in at 80th. And Yeah, it was interesting in the sense, and one of the things that we're going to think through next year is, September was really dry across Southwest, which we're talking about last podcast, and a lot of people scored, and in fact, Ben was gaming the game by basically going near zero on all of the cities, and so we got to figure out. It's just more. The median is right around zero for September rainfall, and so it's kind of an easy guess to go dry, and so we'll have to think through a little bit about how to make September not so easy to game and whatnot. But we'll think through that. I don't know, Mike. Did you have fun playing it?
Yeah, I totally did, and we got to talk about that September a little bit more too, because I get it that the median. Yeah, I suppose that's right. And the median is zero, but there is like the shakeup that occurred. And you can think of plenty of Septembers in the past where at least one of those cities is going to get whacked with something. So it's not a lot different than me playing my climatology every month, which clearly doesn't work in instances like this summer.
No, it's just like if you're playing by the numbers, and if the median is zero, then it's hard to argue for guessing anything other than the median. That's basically you're right. It's basically climatology, but in these distributions that are skewed, average isn't the greatest example. I think average in Tucson is something like, I think September brings an inch or a little bit more than an inch. So, which we didn't get. And had we got it, Tucson would have finished second. Yeah, so I don't know. I think we should move on from the monsoon. We do a nice recap in that other pod that's going to drop soon after this one. Unless you have any final parting shots on September, which we didn't really talk about in that other podcast.
The core of the monsoon activity really ended the first week of September. And then it actually totally cool. We bracket the monsoon season June 15th through September 30th. And we count that, but the rainfall that was occurring later in the month was really, we call it transitional. It was more of the kind of the mid-latitude kind of fall winter signal already creeping in, and that kind of segues into what we saw the rest of the even through the last couple of weeks.
Yeah, so let's talk a little bit about October, because it hasn't been completely dry. There's been some rainfall up in the northern half of the Southwest and in the southern. I think just Trace and Tucson. Phoenix got a little bit in October, and Flagstaff's gotten inch and a half or a little bit more. But aside from that, I believe, Mike, you were saying that it's been a fairly active, which is common, I guess, but it's been a fairly active October. Can you speak a little bit more about what's sort of been going on synoptically or regionally?
Yeah. So again, kind of just thinking about that transition from, real good subtropical ridge position that we saw much of the summer, displaced to the north, shifting over to the east, and sometimes to the northwest of us, keeping us under that deep easterly flow. It started to retreat by the beginning of September. So we had a really pretty good event at the end of August into the beginning of September. And then it did slow down quite a bit the middle part of September. And then we did see a couple of events that we would consider more transition. And so that's through the end of September. The last 4 weeks, the monsoon ridge retreated back to the south, kind of got bumped over to the east. And we did get to this more upper level westerly flow. Again, that more mid-latitude storm track kind of dropping down. And across the whole kind of eastern Pacific, you saw a pretty strong sort of trough ridge trough pattern. And so what it did is it allowed numerous events actually to drop down the West Coast. And then it's brought precipitation to the Pacific Northwest, to much of California, even into Southern California. And then that has caused our temperatures to kind of bob up and down. And we've had a couple of pretty strong cool events that has led to some freezing in parts of Arizona, which is kind of about on track as far as first freezes for say the southeast part of Arizona in particular. And then I think you kind of hinted at this too. There was a really strong atmospheric river rain event that really clobbered Northern California within this last week. That trough actually moved across and has cooled us down. And so we're now kind of in this roller coaster of typical fall weather here in the Southwest. Yeah,
so that atmospheric river is worth talking about, because it was in the news quite a bit. And it was actually an impressive storm. I believe some places experienced, like Sacramento, I think, experienced its wettest day on record. I think it's 5 inches or so fell. I'm just looking at the precipitation map and of the West here, and there's this incredible line of above average monthly values that basically go southwest to northeast across the entire West, and you basically just see where this atmospheric river trended, and there are these like super impressive. They're subtropical cyclones. I mean, I believe they had hurricane force winds. Correct me if I'm wrong there, Mike, or maybe there was really strong winds associated with this. But when you look at the satellite image of these things, you get this counterclockwise rotation, and it's just flinging these, to the south of it, it's just flinging these bands of clouds, vapor, high amounts of vapor, kind of just like as if you were sort of just like twirling around, and you can imagine what the wake of that twirling would do to the air, and that's what was going on. And for 3 days, basically the 14-day total as of a couple days ago along the coast, sort of right from San Francisco and north was, 11 and a half inches of rain. And then inland in the mountains, it was over 13 inches or 12 inches rather. So huge amounts of water. That was impressive, not just for their water, but an important event to sort of shut down, at least in that part of California, the fire season, or that's what people think. I mean, it blanketed the mountains with snow, so really, really helpful to shut down what is often still a fire season up in that part of the country.
I think Sacramento, up until it was either this event or an earlier event in October, had set was either the longest or the second longest dry streak from last spring to this particular event. So that kind of points back to what the fire activity they were seeing there. It was very, very dry, very, very hot summer in it. You have to go all the way back to last winter. Again, that is kind of their dry spell, but this one was particularly dry. And as you said, that atmospheric river was part of what they call sort of bomb cyclogenesis. And so it's the idea of like you have those nor'easters on the East Coast, and actually a nor'easter was occurring at that same time as this one was occurring. And so they had really, really rapid intensification of that low pressure system. One of the buoys off of the California coast set a record, or maybe it was off the Pacific Northwest coast, set a record low barometric pressure. And that's, hard to do. And that's going to be indicative of that pressure gradient that's going to drive the winds that you were talking about as well. And yeah, so this map I'm looking at here from NOAA and their precip analysis was showing in the last 30 days, the kind of a stripe from San Francisco to Sacramento, and it reaches all the way up into parts of southeast Oregon, have anywhere from 400 to 600% of average for this last 30-day period.
So how do the bomb cyclones, as they're known now colloquially, but they have a scientific root to the word, how do they actually form?
The ones I'm most familiar with are on the East Coast. This one's a little bit different. The ones on the East Coast end up having really rapid intensification due to really, really strong temperature gradients that emerge between the warm Gulf waters, the Gulf Stream off the East Coast, that typically is interacting with super cold, dry air coming out of Canada. And so when you collide those air masses within a low pressure system, you can have really, really rapid deepening and falls in pressure. So on the West Coast, you don't have real warm water. So I actually don't know what caused dynamically. It must have been some really, really circuitous route in the jet stream that actually can lead to helping sort of enhance vorticity and enhance that deepening of the low pressure system. And it might be, and I haven't really looked back at this, it might have been one of those typhoons that got absorbed into the mean flow that caused the real strong kind of wavy jet stream pattern, which would be part of that intensification as well. I bet if we kind of dig into that a little bit, this is the time of year that you do see that kind of absorption of those tropical storms into the mean flow that will then impact the weather downstream.
Yeah, so it's worth mentioning a couple things related to this atmospheric river. The first is that Southern California did not receive nearly the brunt of the rainfall that sort of the northern half of California. And so there's still a bunch of fire risk for Southern California. In fact, I think it was 2017, the big late season Thomas fire in Southern California happened. So, and that was in December. So there's still that chance. And of course, there's the Santa Ana winds at this time of year, which can really drive those fires. But, I am following a few people, fire people, and they think that this event probably shut down the fire risk, or at least severely curtailed it for the northern half of California. So that's a good thing. The other thing is about the atmospheric rivers is these are events that are common. They happen at this time of year, and they're the events that generate the really extreme precipitation days, if you will. So normally when you have exceedingly high rain or snow, not normally, but often they're associated with these atmospheric rivers. And again, it's because that the circulation in the low pressure is helping to funnel just really moisture laden air up into California, and it goes inland too. And Mike, there's usually a sort of climatology associated with these ARs. Are you familiar with the climatology of the AR, like the seasonal progression of them? Do they sort of start more, the frequency is higher early on in the winter north and sort of progresses south, or is it vice versa? Do you know that offhand?
Well, I mean, if you think about it in terms of sort of the mean jet stream position, it would have a more northerly track, and that would then gradually move a little bit further south as you had the mean jet kind of drop a little bit further north, just due to the whole northern hemisphere cooling off and looking where that temperature gradient is occurring. So early on in the season, the temperature gradient typically is more northerly displaced, and as the whole hemisphere cools off, it comes further south. But I think that this one is not uncommon for October. It's definitely kind of a wintertime thing. But you had looked at a paper too recently, and we should kind of dig back into this. We've done some atmospheric river climatology discussions in the past. I don't have them quite on the tips of my fingers right now, but this one was really quite fantastic, and the timing couldn't have been better because October rain is really important for helping tamp down and end the fire season in California, and transitioning into having a better season hopefully after this.
And the other thing that's really important is, particularly after a long dry spell, is the early season puts down soil moisture, which makes the subsequent snowpack and the water efficiency that comes from that snowpack much greater in the spring. So it's a nice vanguard, I think, to spring runoff, a good spring runoff season. Of course, if it shuts down and no more rain and snow happens, which is possible, I guess, then this goes to waste. But it's good to get this in early, saturate those soils, particularly with the big event. Of course, the flip side of that is I'm sure there was a lot of flooding, a lot of landslides. I'm sure there was some destruction, and I haven't not up on the news to see if there was more tragic destruction. But these are big events, and so those bring pretty high impact. But the good side of it, again, is sort of laying the environmental conditions in a way that favor sort of a good water season.
Yeah, definitely. And the track of this particular sort of plume of precipitation that was fed by the atmospheric river, it occurred over some of those mega fires that had occurred over Northern California. So there was a lot of concern about flooding and debris flows with all of that precipitation happening exactly in the same area where those large fires had been burning just weeks to months prior.
So in the northern Sierras, I was looking at the California Department of Water Resources, and they track sort of 7 or 8 high elevation stations and monitor precipitation. And currently, more rainfall has fell through the date, through October 27th, than at any time previously. So it's off to a gangbuster start, which is a good sign. I mean, in fact, the same amount of rainfall, so 12.5 inches on average, fell across these one, two, three, four, five, six, 8 stations. That and that amount usually doesn't happen until mid-December. So we're close, like a month and a half, close to 2 months in advance. But we'll see. We'll see how things go. But good start. We like that. We hope that happens in the Upper Colorado River Basin as well for us. But the other thing I wanted to say about the climatology of the ARs is, yeah, the research that I was doing, just looking at a couple papers, was trying to look at the ENSO signal and whether or not these ARs are more common in La Niña events, which is what we're currently experiencing, than El Nino or neutral events. And they are. So these are, I don't have an explanation for that off the top of my head, maybe you do, but statistically the association is greater for the frequency of atmospheric rivers in La Niña events than not.
Yeah, I was going to add too, just on to draw that kind of weather pattern closer to the Southwest, is that in the last 30 days, we did end up having a couple of rain events that did impact sort of northern parts of Arizona, even a little bit of precipitation in far southwestern Arizona, and then parts of northern New Mexico. So we weren't completely left out of these events. It hasn't been super wet here, and the storm track really has been to the north of us. But a couple of these lows, as they've come across, they definitely have cooled temperatures out. Some of them actually did drag some precip through across the region. So, not too bad. We're still, there's plenty of good soil moisture from the monsoon, that kind of came into retreat in September, and we've had these subsequent events. So it's not like we completely dried out and it's cooled off. So this is, we're in a good spot as far as sort of thinking about short-term drought relief. Yeah,
that's a good segue, because unless you have anything else you want to add about October, the last couple months, and if you don't, I think the good segue is, when we talk about climate, there's always like something good and there's always the flip side, something bad. So before I go there, that'll be my tease. Mike, is there anything else you want to say about let's say the last couple months?
This October it's been kind of unremarkable. It's been nicely close to average in a lot of respects. Even the temps have been fairly moderate over the last 30 days.
Okay, great. So the positive, according to me, is that at least the short-term drought conditions are in a much better place than they were a year ago. Again, we've talked about maybe the drought monitor isn't the best tool to compare across time, but it gives us an indication. And a year ago, it wasn't even as bad as it had gotten, because we experienced a really dry winter. But just in comparison to 1 year ago, three-quarters of Arizona was in a sort of extreme drought category, with some exceptional drought, and those are like the two highest drought monitor categories. Now we're in a much better situation. Of course, there's still drought, but most of Arizona is either a moderate drought or just abnormally dry, which the drought monitor doesn't consider a drought category. So there's been improvements largely from the monsoon that we just experienced. So that, I think, is the good. Mike, is there other goods that we want to talk about besides the drought conditions?
The monsoon was so overwhelmed. I mean, I feel exhausted from all that precipitation. Okay,
so there's always something good and something bad that we can talk about. There's a flip. A good wet monsoon, brings with it, higher flood risk and flash flood risk, right? So
I got you.
There's always the flip side. So maybe I shouldn't be such a downer, but the negative, I think, is as we think about this winter season, it comes into focus, and that's the water situation. And I think it's gained quite a bit of press, particularly, the Colorado River, everybody focuses on, much less so the Rio Grande, but those are the two main sort of arteries that, provide a lot of, water for, urban populations, rural farming and whatnot. Colorado, 40 million people across 7 states, and also Mexico. So it's a big deal. I was digging around. There's been some really good information. For those who haven't seen John Fleck's blog he's really one of the go-to experts on Western water, Colorado water. He's had some really great information. Just a couple things to note. Lake Mead is currently at, and it has a water level elevation of 1,067 feet above sea level. And the last time it was this low was 85 years ago in 1937, as it was filling, right? So we're at really historical lows in Lake Mead. But the important thing about the Colorado is you have to think of the Colorado River not just from one basin perspective, but Lakes Mead and Powell are really operated in synergy, and it's super complex. I'm not going to try to like parse out like how it all works, but Lake Mead and Lake Powell have to be thought of as like a giant reservoir, one reservoir, even though they're two. And so Lake Powell currently has a elevation of 3,545 feet above sea level. And the last time it was this low was in 1969, or 60 years ago. You know, that was just after it was starting to fill. Actually, no, it was about 5.5 years after it started to fill. So the point here is we're at these really low levels. Lake Mead is at a level that is triggering some conservation measures that largely affect Arizona. Yeah, the projections aren't very good. And so why I bring all this up is the winter here is so crucial, I think, for our water supplies. And there hasn't been many winters that have actually partially refilled some of these two reservoirs. The monsoon was wet in a lot of places, but that does not that much for our water supply.
I think that the upper basin is not monsoon country, right? And so I think that, you know, so like the Colorado River Basin and then the Elephant Butte it was in a part of the monsoon that actually didn't see as much activity, you know, so we had some water situations that didn't get hammered as much by the monsoon signal as we would have maybe hoped. And they also don't typically have much, the needle doesn't move a lot with summer precip anyways. Right. I do want to point out though, that Salt River project actually saw like Roosevelt, it actually gained elevation because it was, you know, that the salt watershed just was kind of part of one of the epicenters of the monsoon activity. But that's such a kind of a local example where the monsoon can sort of like start to kind of turn. But and again, it typically Roosevelt loses water through the summer, regardless of the monsoon. It did not fill a lot, but it filled a little, which is really, really unusual, right? And it's still down from where it was a couple of years ago. But I thought that was kind of an interesting comparing and contrasting to some of the other reservoirs responded through the monsoon season.
That is a good point. We've talked about this before, and another important part of this is the conditioning of the soil moisture can help during the monsoon season. Although I'm not sure I completely buy that, because like, wouldn't it, no matter how big, like, isn't the soils like after like a 3-week dry spell probably exhausted and dry now anyway, or does it stay around for more than that? Yeah,
and it's interesting because I've got a project I'm working on with a graduate student where we're looking at sort of the time lag between water and soil moisture. And at about 10 centimeters, it's about the variability over about 4 weeks. And as you get down to like 20 and 30 centimeters, it extends out several months. So you can start to see the seasonality of precip show up, you know, at a 3 to 6 month time lag at about 25 to 30 centimeters.
Well, then that does matter.
Yeah.
So maybe we're not seeing it explicitly, the monsoon effect, but it's there for some of these basins. But you're right, like Colorado, yeah, it's not monsoonal, and for the Colorado River, you know, 70-80%, I believe, of the water that flows through the Colorado River really comes from the seasonal winter snowpack. So, and I would also say I looked a little bit on the Rio Grande, particularly Elephant Butte, which is a big reservoir sort of just north of Las Cruces. It's I think it's something like 2 million acre feet. And to put that in perspective, I believe Lake Mead is 25 million acre feet. So prior to the monsoon, the projections for Elephant Butte were for it to have just 10,000 acre feet remaining in it at the end of the water year, so at the end of September. My recollection, this is the lowest it would have been since it began filling. And the monsoon itself, like you said, it wasn't as wet as it was, say, in central Arizona, but it wasn't like it was last year. It did add water to Elephant Butte, and it rose from a projected 10,000 acre feet to 60,000 acre feet, which is still only 1.5% full. So all that is to say is the Rio Grande, the major artery there, is in a situation where it needs, if it's a dry winter in the Colorado mountains and Utah mountains, it's going to be again, this water conversation is going to be even more critical that people are paying attention and figuring out solutions.
It did rain across much of the Colorado River Basin, so it wasn't epically bad. Utah had a pretty good monsoon. I mean, these are areas that are not core of monsoon, but the upper basin did see precipitation this last summer, which is, it did not, the previous summer very much at all. So already I think the monsoon has set the stage for, if we can get precip on top of, decently recharged soils, they have a much better opportunity, as you noted, to turn into much better runoff efficiency into next spring. But now it's like the big question mark is okay, what's going to happen, for the Southwest going forward for this upcoming winter? And I'm thinking more broadly about Colorado, Utah, as well as Arizona, New Mexico.
Right. And so that brings us to, I think, the La Niña that is brewing. First of all, it's a second year La Niña. It's a double dip La Niña, Mike. And that is, again, that it's not a slam dunk, but it tips the scales, at least for the Southwest. So we should talk about the difference between sort of the southern part of the U.S. and just like north of Arizona, New Mexico, and Colorado, because there is a sort of a hinge line when it comes to a sort of ENSO precipitation signal. But this La Niña does tip the scales towards a drier winter for us.
Yes.
I love talking about I love talking about ENSO because at some point it feels like, well, what more can we say?
I know, and we joke that we've said all we need to do is splice in some of our old conversations here. So the last double dip La Niña event was 2011. What was it? It was the 10-11 La Niña, and then 11-12. 11-12 was the last double dip La Niña we saw. And I guess there's not really any question whether or not the La Niña is going to occur. It's already it's officially present given the NOAA advisory. It's now a question of what will be its ultimate magnitude and how long will it last. And that, I think, does translate into the potential teleconnections across the Southwest. And I think is the southern part of Arizona, southern part of New Mexico tend to have a much more reliable dry signal than, say, even the northern parts of the Southwest. And as you get in the upper Colorado River Basin, there's not actually a very good La Niña, El Nino correlation with winter precipitation.
All right, a couple things, because I think there is something that we can talk about. One, it's this idea of a double dip, which is more common in La Niñas than El Niños. We could talk a little bit about that. The other thing is I stumbled upon, I love NOAA because it's a surprise every time I'm like Googling and I'm like, oh, there's a new website that I haven't seen. And I maybe you had seen this before, but they actually do these probabilistic forecasts of the magnitude of ENSO. Have you seen this website that I slacked before? Oh, you have?
It's actually, you and I've talked about it before too.
I've already forgot about it.
Yes.
That's hilarious. All right. So for the November, December, January, the probabilistic forecast is that there's a greater than a 92% chance that the La Niña will be persistent during this 3-month season. There is a 57% chance that it will be a moderate event, at least a moderate event, and a 14% chance that it will be a strong event. So, and then if you just move forward 1 3-month season, so sort of the heart of our winter, December, January, February, again, it's like a 50% chance of it being a moderate event and a small chance of it being a strong event. So my take, and almost a certain event that it will be weak. So my take is that we got La Niña. It's going to be around for least the heart of the winter. And it looks like if we were to, just bet on this, if we were to believe this forecast, that our best bet would be on a sort of a moderate event.
That makes sense. And typically in a double dip, the second La Nina is weaker than the first.
And last year, remind us, so we were borderline strong, right? Moderate to strong. I think that the strongest temperature anomaly or the coolest temperature anomaly ended up being like what, 1.4 degrees Celsius or something. I think that's what it was.
Yeah.
1.3 actually last year. So let's talk a little bit about this double dip, because this is a curious feature, right? Like we don't often talk about double dips and El Niños. And so if you look at the historical record, a couple things bubbled to the surface. One, we only have 20 in the observational record. We only have 20 La Niñas to draw from. So it's not a huge sample size, which is kind of crazy when we think about how much, well, there's good modeling behind this too. So I don't want to like discredit, like, I don't want to be misunderstood that there's really good modeling. We understand the dynamics, but nonetheless, when we're trying to find statistical relationships and really trying to understand the dynamics, like we don't have a big sample size to both go from. That being said, so we have 20 La Nina events in the observational record. Of the 20, so there were 12 first-year La Nina events, and then for those 12 events, the second year, 8 of them were double dip La Ninas. That's how you get 20, 12 plus 8. So in other words, 12 events, 8 of the 12 events were double dip La Niñas, and 2 La Niñas in that first year ended up becoming El Niños, and then another 2 ended up becoming neutral. So they're quite common for La Nina. Now that's not the case for El Nino. Mike, I looked into this. I have to say that there's some really good papers that I don't understand. So I'm relying on a sort of synthesis and our colleagues from NOAA actually that spend a lot of time trying to communicate the complexities of El Nino and La Nina to the public on their, what is a really good resource, I think, and some really brilliant scientists write it. It's called the ENSO blog, but they sort of tackled this. And so let me try to summarize at least conceptually what's going on here. And I think you have to think about ENSO and its sort of 2 phases, discarding neutral as like the middle phase. Like we tend to think of El Nino and La Nina as these sort of opposite phases. Well, they're not opposite in their characteristics. So an El Nino event are warmer sea surface temperatures, above average sea surface temperatures. La Nina events are cooler than average sea surface temperatures. But the locus of the strong anomalies are different. So they don't occur in the same part of the Pacific Ocean basin. That is to say that in El Nino events, the warm waters are shifted more to the east, and the cold waters in La Nina events are shifted more to the west. So that difference matters. The other thing is that El Niños tend to have greater anomalies. So you can get an El Nino with, let's say, an average of 2.5 degrees Celsius above the long-term average, whereas La Niñas are less so. So the intensity of the sea surface temperature pattern changes, as well as the spatial pattern of the water, and then that those 2 changes, that at asymmetry matters for the atmospheric and ocean feedback, and basically, and it gets really complicated. Nonlinear dynamics. This is where my eyes glaze over, and I don't really understand it. But conceptually, what's going on is that during an El Nino event, because the winds slacken, the easterlies slacken during an El Nino event, there is more efficient export of that warm water that's building up in the tropical Pacific than during La Nina events. And so it's the El Nino events sort of turn over quicker. So that warm water is able to move out of that area at a quicker rate than during La Nina events. And so consequently, that sort of feedback isn't kicked into the opposite state as quickly during La Ninas than El Ninos. And consequently, you often see this 2-year La Niña event, double dip La Niña event. But also, as Mike pointed out, the second go around tends to be weaker. And there's a lot of still unanswered questions for this. And obviously I probably didn't do the complexity of that justice, but I tried. Mike, you got anything to add there? Did you learn something?
Yeah, I think that we might want to do kind of maybe an explainer too, to explain to each other how we think about El Nino and La Nina and the El Nino Southern Oscillation. I was trying to remember the term, but there's a term in the literature that talks about or thinks about the El Nino Southern Oscillation in terms of sort of charging up the West Pacific with energy, and then that energy gets released during El Nino events, and as you said, is dispelled it's basically exhausted to the north and south. And then La Nina doesn't have that same kind of sort of charging release kind of mechanism, which I think allows it to have sort of, it can kind of come in and out of neutral and La Nina state a little bit differently, asymmetrically than you'd see with an El Nino event.
Yeah, exactly. And maybe just to pull back and say what's important here, it's to think about these two phases a little bit differently. Like we can't think about, and particularly when we're thinking about the future, like what happens to El Nino might not happen to La Nina and vice versa. These things have different expression. They look different. They cause different teleconnections. They're opposite phases of the same kind of process, but they express themselves differently. And yeah, I think that's the big point.
The indices go, they go positive, negative, and they kind of trace sort of in a clearly not a predictable sinusoidal path over time because of their complex nonlinearity and the complex dynamics between them. And I think it's why it's so hard to do seasonal forecasting or seasonal outlooks, because they're all mostly based on the state of El Nino Southern Oscillation in, say, this sort of spring, summer, fall period to do the outlook for the winter. And those outlooks themselves for the El Nino Southern Oscillation, have so much uncertainty due to this complexity.
So that sort of begs the question then, Mike, well, what does this mean, particularly in the context of the upper Colorado River Basin, the upper Rio Grande Basin? What does this mean? What do we think is going to play out in terms of rainfall and snowpack?
I don't know, quite honestly. You can go back and look at, say, the last of the double dips, but I'm not sure these analogs are going to be all that apropos. If you go to the Climate Prediction Center seasonal outlooks, the probability anomalies, meaning this sort of certainty in the precipitation outlooks, are going to be across the southern half of the Southwest. So you already see New Mexico and into Texas with a kind of a stronger probability anomaly than you even see into Arizona. And you see it fade off as you get into the upper basin. So I don't know. I think anything is possible for this upcoming winter for the upper basin. I think Arizona is going to struggle to get to average. And I think the southern part of the state probably will be drier than average. It's just, that's typically what plays out with these La Nina events. And I think New Mexico is really going to struggle as well, getting to the end of this winter.
Yeah, I think you're right, Mike. It's going to struggle to be a wet winter, but I think maybe we can sort of weather that a little bit with the monsoon season we had in southern Arizona, and it really is, in my mind, all eyes focused on the higher country to our north.
Yeah, I completely agree with you, and I think that we just don't have a lot to go on for the upper basin at this point. I'm just peeking at the 2012 precip in the spring, so thinking of the second year of that multi-year La Nina, and it's not good. So the Southwest and proper actually had pretty good precipitation in November and December. So 2011, going into 2012. So, I think it's often related to these kind of troughs and kind of plumes of moisture that can come up with atmospheric rivers. And I think we did okay there. But if you look at sort of January through the rest of the spring, it was very dry across Arizona, New Mexico, and Utah and Colorado as well.
Yeah, I'm kind of bummed.
I know it's not a great spot to be in, for sure.
There is one recent paper, a review article about ENSO in a warming world, and I just want to get myself up to speed on sort of the current state of of knowledge related to that, because ENSO is a leading driver of wintertime rainfall variability, which is so critical. And, a major question about how things will change in the future is about how ENSO will change. And I know, from the last time I sort of did a deep dive into the state of the knowledge, I know that there's, a whole bunch of questions about whether or not we even know, whether or not we have the tools available to understand ENSO in the future, which calls into question the precipitation. But I think it's also worth saying that it's a different ballgame with temperature. We've said this before. And just in terms of the Colorado River snowpack, there's been good modeling studies that suggest that just the sensitivity of water runoff is something like for every degree of warming, runoff in the Colorado goes down by about 6%. And that's just a temperature signal. It's not so much a rainfall or snow signal. So but nonetheless, the other side of the equation, the rain and snow side of it, is important. So maybe we should think about reading some of those papers that have come out.
Yeah, it'll be interesting to kind of reflect on that as we're watching the conditions unfold across the region, and just to try to get our heads around what we might expect. Because, what would it look like? I mean, we'd have to have something pretty remarkable happen across the upper basin to really change the story at this point.
Well, to markedly change the story, I think you're right. But I also think it does seem like, given the increases in temperature, that no longer does sort of an average year produce the same amount of runoff. We actually have to have, a pretty good winter, a pretty much above average winter to have like a good water runoff year. And so in those conditions, we're stacking the deck against us in terms of snowpack. So to answer your question, I mean, I think like a good winter will change the short-term picture, but we're still within this longer-term trend that, I mean, we need to flip in the regime. We need to go back to like pre-2000. We need a pluvial we need a pluvial.
So we need what? Miracle March, fantastic February, jubilant January, dang awesome December. And what would be November?
I needed alliteration here. And I need to have like a C. This was great fun. Thanks everybody for tuning in, and look out for, we've got a double dose of 2 pods to go with our double dip La Niña. So enjoy everybody, and we'll come back in a month, and hopefully we'll have a rosy snowpack condition to talk about. Thanks.
Thanks, Zach. See y'all.
All right, bye-bye. This is like a tongue twister.
Yeah, I thought you weren't going to make me do this. Try to explain the differences. I did learn something. Yeah, I am a student. I'm sorry, I got a cat who's really, really insistent about his opinion of the El Niño Southern Oscillation.
I waned there at the end, but we pulled through.